Now that we know how to make the few basic graphs of the circles and the line through the origin, we want to learn how to make other graphs in polar coordinates. Now we can always graph in polar coordinates the way we learned how to graph in rectangular coordinates. Namely, you find some points and you kind of fill in the curve that connects those points, sort of like connect the dots. But you have to be careful not to make too big a logical leap when connecting those points, because polar curves are not nearly as straightforward as rectangular curves. And I mean that literally and figuratively. They're not straight, they're curving around a lot. All right. So I apologize, there was a little bit too much in the instructions here. So if you're watching this in winter 2020, I've simplified it a little bit. All right, so we just want to describe the graph of the polar equation. Now the polar equation is really small, so you might miss it if you blink and it's not there. The polar equation is right here. R is equal to theta. There's your polar equation. So it's a very simple polar equation, and it's an interesting one. And we're going to let theta be greater than or equal to 0. And I'm giving you a hint on this one, which is to use multiples of pi over 4. Now, there is an exception to that, which is in quadrant 1. I'm going to mess around with quadrant 1 a little bit more than I normally would. Well, 0 is kind of easy. 0 goes with 0, so that's easy. And I'm going to go pi over 6. Now, remember, in this particular problem, this is really simple, right? So r is equal to theta. So whatever angle I pick, that's going to be my r. So it's pi over 6. Pi over 6 is about 0.523. Then pi over 4, right? Because it goes pi over 6, pi over 4, pi over 3 for basic quadrant 1 angles. Pi over 4 is about 0.75. Then I'm going to do pi over 3. I'm not going to do this for all the quadrants, but quadrant 1 is particularly tricky. So pi over 3 is about 1.05. And then I'm going to skip over to pi over 2. Pi over 2 is about 1.57. And now I'm going to go, the pi over 4 is like it recommended. So it recommended multiples of pi over 4. So I got pi over 4, but I got those other two in there just for the sake of it. Pi over 2. Now I'm going to go over here. That's 3 pi over 4. 3 pi over 4 is about 2.36. And of course, right, so first 45 degrees, right, 245 degrees makes 90. There's 135 degrees, and then 180 degrees. So pi is the next multiple of pi over 4. So 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 over 4 makes pi, and pi is about 3.14. So this is 4 over 4. This is 2 over 4 right here. And then, let's see here, 2 pi over 4, I should say. Now let's see, pi, let's go, the next 45 degree angle is right here. So that would be 5 over 4. So it goes 2 over 4, 3 over 4, 4 over 4. So 5 pi over 4, which is about 3.92. Then 6 over 4, but 6 pi over 4 is 3 pi over 2, which is down here, right, 270 degrees. So that would be 3 pi over 2 is about 4.71. And then over here in this quadrant, we have 7 pi over 4. And then 8 pi over 4. 8 pi over 4 is actually 2 pi. So this is about 5.49. And of course, 2 pi is about 6.28. All right, so now we have a whole host of points, and now we're going to graph those points. Now the hardest part is actually the first bits. That's why I kind of put them in there. So it starts off at the origin, no problem, so 0, 0. Pi over 6 is this radial line right here. So on that radial line, I want to go out to a radius of about 0.523. Now keep in mind, this ring right here is 2. So 2 rings in right there, that's 1. That's the 1 ring. So 0.5 is right there. Right, all apologies to Tolkien later. All right, so 0.5 is like right there on that radial line, a little bit past 0.5. And then on this radial line, I want to be at 0.75, which is kind of halfway between the 0.5 and the 1. So right there. And then at pi over 3, I want to be at 1.05. So the pi over 3 radial line, I want to be just past the 1 ring. Again, apologies to Tolkien. And then at pi over 2, which is this radial line, I want to be at 1.57. So 0.5, 1, 1.5. So 1.57 is like right there. And then I'm going to connect the dots. And it goes like that, right? So your curve swings through those points. Now, from that point on, we're going to, because those are the hardest ones for this particular graph. All right, so now at 3 pi over 4, I want to be at 2.36. So this is the 2 ring. So that's 2.5, and that's 3. So 2.36 would be kind of 2.5 would be halfway. So on this radial line right here, which is the 3 pi over 4 line, I want to be past the 2 ring, but not quite to the 2.5 ring. And then at pi, I want to be at 3.14. So 2, here's 4, there's 3. So I'm just going to be just past the 3 ring. And then at 5 pi over 4, which is this radial line down here, 5 pi over 4, I want to be at 3.92, so almost to the 4 ring, which is this dark ring right here. So maybe right there. And then at 6 pi over 4, which is this line down here, I want to be at 4.71. So 4.71 is past 4.5, but not quite to 5. 5 is that ring right there. So I'm going to be right in here somewhere. And then 5.49. So on this radial line right here, I want to be out 5 rings and a half. So here's the 4 ring, 4.5, 5, 5.5. So I'm going to be there. And back up at 2 pi, I want to be at 6.28. So just past the 6. And we connect it through. It's a spiral, all right? It's a counterclockwise spiral. With radial stretch as theta increases. So with more radial stretch as theta increases, right? Because it's pretty tight in here. The spiral is tight, and as we get out, it gets larger and larger and more loopy. Now I know what you're thinking. You're thinking, can I see this in Desmos? Why, yes, you can. And it's easy to graph in Desmos. I'm not going to bother showing the calculator because who cares? We all need Desmos. And here it is. Look at that. Whoop. I didn't mean to do that. There we go. It's a spiral. All right. It's a spiral. There's that first quadrant. There's that second quadrant. All right. If I stop it at 2 pi, that's where we stopped. Right there. That's where we stopped. But of course, keep going and going and going, which would be a pain to do by hand, but Desmos does it really nice and easy. If you want to see how I'm graphing in a Desmos, I'm being a little fancy with it because I wanted to actually graph it a little bit more fancy. So I'm having it graph r equals a theta, but I let a be equal to 1. And then I'm telling it to graph for theta is less than or equal to b, where b is some number between 0 and 12 pi. So that's why the spiral is happening. And then I wanted that point to kind of show up a little bit. So that's this part right here where I'm just graphing the point. So if I turn it off, you can see that's the curve. And then this is the point, x comma y, right? So AB cosine theta, AB sine, right, FB, etc. So you're welcome to steal this graph if you so desire, but you'll notice it's a spiral. Polar graphs are so cool.